Hello everyone. In this video, we will learn about descriptive statistics. First is summarizing data for a categorical variable. Frequency distribution. A frequency distribution is a tabular summary of data showing the number or frequency of observations in each of several non-overlapping categories or classes. A frequency distribution is a representation either in a graphical or tabular format that displays the number of observations within a given interval. The frequency is how often a value occurs in an interval, while the distribution is the pattern of frequency of the variable. So I will show you frequency distribution with an example so you will better understand. For example, this is a data of 50 soft drinks purchases. This includes Coca-Cola, Diet Coke, Pepsi, and so on. So, how we can make frequency distribution of this data given in this table? For example, the first string is here, that is Coca-Cola. So you can count Coca-Cola here, 1, 2, 3, and 4, and so on. So Coca-Cola appears 19 times. So the frequency for Coca-Cola is 19. For the Diet Coke, you can count in this table. So it's appear 8 times, same like Dr. Pepper's, 5 times, and Pepsi 13 times, Sprite 5 times, and the total is 50. That's how we do frequency distribution for a categorical data. To know about categorical data, you can watch my previous video. And how to summarize or do frequency distribution for this data with a software, you can watch my next video. Relative frequency and person frequency distributions. A frequency distribution shows the number of frequency of observation in each of several non-overlapping classes. A relative frequency distribution consists of the relative frequencies or proportions or percentages of observation belonging to each category. So frequency distribution you already understand, and the relative frequency of a class is equal to frequency of the class divided by n. So the percent frequency of a class is the relative frequency multiplied by 100. So here is the soft drinks purchases, and the relative frequency is given here, and the percent frequency is given here. Bar charts and pie charts. A bar chart is a graphical display for depicting categorical data summarized in a frequency, relative frequency, or percent frequency distribution. On one axis of the chart, usually the horizontal axis, we specify the labels that are used for the classes or categories. This is the bar chart of the soft drink purchases. We just saw the data in the previous slides in the table. Pie chart. The pie chart provides another graphical displays for presenting relative frequency and percent frequency distributions for categorical data. To construct a pie chart, we first draw a circle to represent all the data, then we use the relative frequencies to subdivide the circle into sectors or parts that correspond to the relative frequency for each class. Here is the pie chart of soft drink purchases. Coca-Cola is 38%, Sprite 10%, Dr. Pepper's 10%, Diet Coke 16, and Pepsi 26. Frequency distribution. A frequency distribution is a tabular summary of data showing the number of frequency or observations in each of several non-overlapping categories or classes. This definition holds for quantitative as well as categorical data. Here is the quantitative data for the year in added times in days. Three steps necessary to define the classes for a frequency distribution with quantitative data are to determine the number of non-overlapping classes, determine the weight of each class, and determine the class limits. Number of classes, number of data items, n is 20, and that data I just show you, and the number of classes can be 5. The weight of classes is approximate class weight equal to largest data value minus smallest data value divided by number of classes. So the class width can be 33 minus 12 divided by 5 equal to 4.2 for the data given in the table. Data, the class limit. The lower class limit identifies the smallest possible data value assigned to the class. The upper class limit identifies the largest possible data value assigned to the class. For the same data, the other times we make the classes, for example, 10 to 14, and then again 15 to 19. So as we mentioned, non-overlapping classes. So the non-overlapping classes mean that 14 is here. So again, here we cannot start from the 14. We must start from 15. That's from 15 to 19. And then from 20 to 24, we cannot start from 19. So this is called non-overlapping classes. And the frequency is 4, 8, 5, 2, 1, and the total is 20. To find the relative frequency and percent frequency distribution for quantitative data in the same manner as for categorical data. Relative frequency of the class equal to frequency of the class divided by n. Here is the dot plot. It's a horizontal axis shows the range of the data. Each data value is represented by a dot placed above the axis. Dot plots show the detail of the data and are useful for comparing the distribution of the data for two or more variables. For the same data, added time days, here is the dot plot. Histogram for this data is given here. What is histogram? A histogram is constructed by placing the variable of interest on the horizontal axis and the frequency, relative frequency, or percent frequency on the vertical axis. Cumulative distribution. A variation of the frequency distribution that provides another tabular summary of quantitative data is the cumulative frequency distribution. The cumulative frequency distribution uses the number of classes, class width, and class limits developed for the frequency distribution. Here is the example. Cumulative frequency, cumulative relative frequency, and cumulative percent frequency distribution. So the cumulative frequency is given here, that is less than or equal to 14. So less than or equal to 14 in this data, we can find, for example, 12 is less than 14, 14 is equal to 14, is also equal to 14, is also less than 14. So less than or equal to 14, the values are given here 1, 2, 3, 4, 4 here. Then less than or equal to 19, that is 12 value can find here, for example, 1, 19 is also 18 is less than 19, 18 is less than 19, 17 is less than 19, and so on. So must be less than or equal to 19. In that case, we can find the cumulative frequency, and then the cumulative relative frequency and percent frequency we have already studied. A cumulative frequency distribution uses the number of classes, class width, and class limits developed for the frequency distribution. And cumulative relative frequency is the distribution shows the proportion of data items. So cumulative relative frequency is equal to cumulative frequency divided by n. And a cumulative percent frequency distribution shows the percentage of data items with values less than or equal to the upper limit of each class. Cumulative percent frequency is equal to cumulative relative frequency multiplied by 100. I hope you understand the frequency distribution.